Lesson 4.5 is on computing with scientific notation, and you'll be able to multiply and divide numbers in scientific notation, as well as add and subtract numbers in scientific notation. And remember, the essential question for Chapter 4 is, why is it useful to write numbers in different ways? Scientific notation is a way to write really large numbers and really small numbers. And in this lesson, we're going to learn how to multiply and divide, as well as add and subtract numbers that are already written in scientific notation. So what we're going to do is we're going to apply the rules we learned in a different lesson, the product of powers and the quotient of powers properties, to multiply and divide with scientific notation. So for the example here, we have a multiplication problem with two numbers written in scientific notation. So we're going to multiply the 3.5 and the 1 to get 3.5, and then since 10 to the 6th and 10 to the 9th have the same base, we can add the exponents. So 6 plus 9 is 15. So we have 3.5 times 10 to the 15th when we multiply those. For the got it section, I'll do 2, and then you can pause the video and try to do 2 on your own. For this first one, we have 4.62 times 8.15, and then 10 to the 5th and 10 to the 9th. The exponent part is pretty easy because it's the same base, 10, and we can add the exponents 5 and 9 to get 14. Now we are going to multiply, and it's okay if you use a calculator, 4.62 times 8.15, and we get 37.653. And this is where 37.653. This is where you need to really pay attention, because that first number in scientific notation always has to be greater than 1, greater than or equal to 1, but less than 10. And this number right here is not less than 10. So what we're going to do is we're going to move it over and make it less than 10, so 3.7653. And then what we're going to have to do is we're going to have to change that exponent. It originally was 10 to the 14th power, but because we shifted it back one more place, it's going to have to be 10 to the 15th power this time because we shifted that. Okay, let's try 1b together. We're going to multiply the 7.53 and the 2.93, and we have a negative 8 and a negative 3 for an exponent there. So that's going to be a negative 11 when we add those exponents together, 10 to the negative 11th power. Okay, I'm going to pull up the calculator, and we will multiply 7.53 times 2.93, and we get 22.0629. 22.0629. In this case, again, we have a number greater than or equal to 10, so we're going to help it out and shift it back one place here. So we have a number greater than or equal to 1, but less than 10. So 2.28, or 0.629. I've already forgotten, 0.629, okay. But because we already helped it out by moving it back one place, I'm going to shave off 1 from this negative 11 and make that times 10 to the negative 10th. Okay, so when you're multiplying with scientific notation, it's pretty straightforward. You just do the multiplying and you do the adding of the exponents, but you do have to pay attention to your answer. Go ahead and try 1C and 1D on your own by pressing pause and working them out on your paper, and then press play when you're ready to check your answer. For 1C, you should have gotten 1.8 times 10 to the 10th, and for 1D, 7.68 times 10 to the negative 1. They threw you a little loop there by not having a number written in scientific notation, so you could write that as 1.5 times 10 to the 3rd, and then 1.2 times 1.5 gives you the 1.8. And then 10 to the 3rd and 10 to the 7th is 10 to the 10th. Same thing on 1D, 1.2 times 10 to the 4th power, and 6.4 times 1.2 gives you 7.68, and then 10 to the 5th and 10 to the 4th is 10 to the negative 1. On the next page, 162, at the top of the page, we have example 2, and this is a division with scientific notation. So we can go ahead and divide the numbers 7.656 and 3.15, and then we can also worry about the dividing decimals or dividing powers with the same base, in this case 10 to the 8th and 10 to the 3rd. We can just subtract those two and make it 10 to the 5th, and then perform the operation of the division on these two numbers to get 2.4. Okay, so for 2a, we'll work that one out together. We're going to start by dividing these two numbers. Okay, so I'm going to pull up a calculator and put 4.62 divided by 1.4, and I get 3.3. That's a good sign because that number is greater than or equal to 1 and less than 10, so I don't have to worry about moving a decimal. And then times 10, 5 minus a negative 9, which is 5 plus 9, and it's 14. 3.3 times 10 to the 14th. Go ahead and try 2b on your own, and then press play when you're ready to see the answer. (4.9) times 10 to the negative 7. And you might be saying, well, negative 9 take away a negative 3 is not negative 7. Well, that's because when you divide that out, you're not going to get a number that's greater than or equal to 1 or less than 10. So you've got to do some work on that number to make sure that it fits that rule, and then you'll have to change your exponent to match that. Okay. On example 3 on page 161, there is a story problem there, and when it's asking you to compare, in this case, how many times greater was something than something else, you're going to actually divide those two to find out. Okay, and the answer is about 7 times larger, and you can do it this way. I just want to show you that there's another way to do these types of problems. If you're given a number in scientific notation, you can always write that out as standard form. So we have 6 and then times 10 to the 6, so it looks something like this, 6 million, okay? And we're going to compare that to 825,000, okay? So I can write both of those out in standard form and then do my division to figure out the answer. So 6 million divided by 825,000 is 7.27 repeating. So that's where you get the about 7 times larger. If I did this in the scientific notation format, I'd have 6 times 10 to the 6, and then divided by 8.25 times 10 to the 5th power. Okay, so the exponents are pretty easy. 10 to the 6th over 10 to the 5th is 10 to the 1st. 6 minus 5 is 1. And then if I take 6 divided by 8.25, 6 divided by 8.25 is equal to 0.727. Okay, so 0.727. And when I multiply that times 10 to the 1st power, if I move the decimal over one place, I still get that same answer of about 7 times larger. Lastly, for example 4, you're going to be adding and subtracting with scientific notation. And take a deep breath, because in my opinion, this is a little bit more tricky than multiplying and dividing. Because when you add with scientific notation, you have to have the same power. So in this case, we have 10 to the 3rd and 10 to the 4th. That will not work. We can't just add these numbers and then forget about the exponents. What we have to do is we have to rename them so that both of them are in the same power. So 10 to the 3rd and 10 to the 3rd, and now we can add 5.45 and 31.2 to get 36.65, and then we had the 10 to the 3rd because it was the same for both, and then we can rename that to match our rule of having a number greater than or equal to 1 but less than 10. 3.665 times 10 to the fourth. Let's take a look at a subtraction problem. We have 2.78 times 10 to the fifth, and then 46,500. We're going to rename that to 4.65 times 10 to the fourth. But we have 10 to the fifth and 10 to the fourth, so different powers, same base but different exponents. So we have to rename. Let's rename the 2.78 to 27.8 times 10 to the fourth. Okay, and you might be asking, how do I know? Do I write it as the smaller exponent or the larger? Okay, and we'll kind of talk about that way. It doesn't really matter, but there is maybe a preferred one that you choose when you're doing these, but we'll talk about that some more. When you get the same exponent, then you can go ahead and subtract like normal and then finish out the problem. So let's take a look at some of the example problems down here. Okay, for 4a we have 10 to the 7th and 10 to the 5th. Let's just take care of that first by making both of them 10 to the 5th power. So this one's good, but 1.7 times 10 to the 7th, if we have to shave off 2 from the 7, we're going to actually move that decimal place back 2 places. So we have 0.017, and then we have 6.25. Okay, so we're going to add those two together to get 6.267, and then we're going to keep our exponent 10 to the 5th power. Okay, let's take a look at 4b. This one does not have a number written in scientific notation, so we'll write that as 8.64 times 10 to the negative 123. Okay, and this one's 10 to the negative 4. So let's just make that 10 to the negative 4 on our original problem. If this is 10 to the negative 3, let's make that 10 to the negative 4, but we'll have to change our decimal place here. So it's currently right here to 8.64 times 10 to the negative 3. If we move that to 86.4, okay, so we have 86.4, and we have 5.67. We can add those two together to get 7, carry the 1, 12, 92.07 times 10 to the negative 4. Okay, and 92.07 is greater than 10, so we have to change that to 9.207. And since we helped it out by moving it back 1 already, we'll change that 10 to the negative 4 to 10 to the negative 3. Okay, again, this is very tricky in my opinion. You might pick it up right away, but in my case, I definitely have to check my work on these. The long way, or another method you could do, is you could change both of these into standard form. So 1.7 times 10 to the 7th, you could sure write that out as standard form with all your zeros here. So let's see here, we have 1.7 times 10 to the 7th, and then 6.25 times 10 to the 5th, that would be 1, 2, 3, and then 5, and then 2, and then 6. Expand those both out and add it up. You're going to end up getting back to the same answer that you got in the first place. But let me go ahead and turn those answers on for the other ones. And I did not get the same answer there on that one that I did when I worked it out. So I'm going to have to take a double look at that, because that actually matches up with this one right here, but I did something wrong when I added them for this one here. Well, I'll have to go back and check that out. Maybe as you're working it out, you can find my error. On 4b, 9.207 times 10 to the negative 3, that's what I got there. okay? And if you try 4C and 4D on your own, again, making sure that you're subtracting on these and you're making sure that your exponents match before you do any operations with these numbers. So on this one right here, I change that to 1.7 times 10 to the 5th power, but I think that I moved it over too many a place to the left instead of to the right. So would it be 170 times 10 to the 5th and 6.25, 176.25 times 10 to the 5th. And then because I moved it back two places, it should be 1.7625. Okay, so that was my error in changing 1.7 to have the same exponent. I moved it the wrong way. I should have moved it two places to the right there. So hopefully this didn't confuse you too much with me having my error in there, but we'll go through a few more problems on a separate video, and you'll do some more practice on your homework sheet. And of course in class you can also ask me some questions about adding, subtracting, multiplying, and dividing with scientific notation.